Hi students, welcome to the problem solving session on gradient. So here they give a scalar field. For that we have to find the gradient. Find the gradient of the following scalar field. Let us see first problem. First problem is v is equal to e power minus z sine 2x into cos hy. Fine. So this is Cartesian coordinate system because everything is in xyz. Right. So first we have to understand the coordinate system, then we have to apply the corresponding formula. So for Cartesian coordinate system, gradient V is given by del V is equal to dou V by dou x ax plus dou V by dou y ay plus dou V by dou z az. This is what gradient for Cartesian coordinate system. V we know. So what is the thing we have to do? Differentiate with respect to x. So first we have to differentiate with respect to x. If you differentiate this V with respect to x, e power minus z cos hy is a constant. If you differentiate sine 2x, what you get is 2 cos 2x, right? Plus ax. Don't forget that. Next, we have to differentiate v with respect to y. So if you differentiate with respect to y, what is the thing? E power minus z sine 2x is constant. So e power minus z sine 2x constant. Differentiate cos hy. If you get if you differentiate cos hy, what you get is sine hy, right? And ay. This is very important, right? Don't think that cos hy is minus sine hy. It is plus sine hy, right? Plus differentiate this with z. So when you differentiate with respect to z, these two are constant. What are that? Sine 2x cos hy is constant, and differentiate e power minus z with respect to z, it will be e power minus z into minus 1, right? So that I make here as minus 1, right? So instead of that I put here minus 1. So az, simple answer, right? So simple problem. Second problem, see, understand the problem first. You see this is the gradient equation for Cartesian coordinate system. Just differentiate it, no problem. You see, what is the input? Input is a scalar quantity. There is no vector, unit vector, so it is a scalar. You see, what is the output? Del v. Del v is a vector because it has unit vector. You see, so gradient converts a scalar into vector. That's why del v is a vector quantity. We know that already. So del v is a vector. Del v is nothing but gradient of scalar. Yes or no? So gradient of scalar is a vector quantity that we must know. Right? Second question we will see. What is the second question? Second question says that v is equal to rho squared z cos phi, cos 2 phi. Right? So what is the gradient? This is what rho z phi. So it is in cylindrical coordinate system, right? So that we have to understand. Rho z phi is there. So for cylindrical coordinate system, gradient is given by del v is equal to dou v by dou rho a rho plus 1 by rho dou v by dou phi a phi plus dou v by dou z a z. Fine. So again, simple differentiation you have to do, partial differentiation. So first thing is differentiate with respect to rho. When you differentiate with respect to rho, these are all constant. What are the constant? Z cos 2 phi is a constant. Differentiating rho squared with respect to rho, we will get 2 rho. So we can write 2 rho z a rho plus 1 by rho. Differentiate this one with respect to pi. So when you differentiate with respect to pi, rho squared z is a constant. Cos 2 phi is minus sine 2 phi into 2. Clear? Plus a phi into a phi. Plus dou v by dou z a z. Differentiate with respect to z. When you differentiate with respect to a z, rho squared cos 2 phi is constant. Differentiation of z is 1. So that is simply a z. So if you simplify that, what is the answer you will get? 2 rho z cos 2 pi a rho minus this minus 2 rho z sine 2 phi a phi plus rho squared cos 2 pi into az. Right? Simple problem. So again you see the input is a scalar quantity. You see scalar, output is a vector. That is gradient is a vector, right? Please understand. Third problem. What's our third question? V is equal to 10 r sine square theta cos phi. Here you see r theta phi. So it must be cylindrical coordinate. Right? So for cylindrical coordinate system, the gradient is given by dou v by dou r ar plus 1 by r dou v by dou theta a theta plus 1 by r sine theta dou v by dou phi. Right? So again, I have to differentiate. First, differentiate with respect to r. So what is the thing happen? 10 sine squared cos theta phi is a constant. Differentiation of r is 1. So simply this one. Next 1 by r. Differentiate with respect to theta. So 10 r cos phi is constant. Sine squared 2 theta. Sine squared 2 theta, if you differentiate, what will happen? Right? So it is cos sine squared is, you can write differentiate as cos sine 2 theta, right? It is 1 by r sine squared 2 theta. We can differentiate that cos sine 2 theta, cos 2 theta into 2. Fine. I think its problem is wrong. Fine. So it is simply sine theta only, right? Sorry, it is simply sine theta. So sine theta, if you differentiate, what you get is cos theta. Here also, please change it. This is not sine square. This is sine theta. In the question, we change it sine theta. So this is also sine theta, right? So it is sine theta, cos phi, and plus, right, 1 by r sine theta, 1 by r sine theta into dou v by dou phi. When you differentiate with respect to phi, 10 r sine theta will be constant. Differentiation of sine cos phi is minus sine phi, right? So what will happen? This r sine theta, this r sine theta will be cancelled, right? So what we get is 10 sine theta cos phi ar, see area with theta a theta, this is a phi, plus 1 by r 1 by r 10r, so we can cancel it, right? So this are cancel, so 10 cos theta cos phi, right, plus 10 minus sine phi now, so we can say it is minus 10 r sine phi. That's what our del b, a phi. This is a theta. Right, again it is a vector quantity, right? So this is the way we have to solve the problem, right? Fine. So here it is, simple problems. You can answer any questions like this, right? So the only thing you have to change is not sine square theta, it is sine theta. Please change it, right? So this simple one, right? So if you have any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.